All right, I am back at it here, and I just want to show you, first of all, that I believe that I have the fisheye problems solved how I want them to be solved for the moment. And yeah, I did that off camera, but we're going to go ahead and dig in to what exactly I did. But one of the key things to note is that this opening right here should be approximately a square. And of course, obviously, hopefully you all can hear me. I'm, you know, it's a small group at the moment. I'm going to double check something. There we go. My pen interface was not working quite right. So that area is a square. Okay. And you can see that we're not getting those bulbous effects that we were getting before. And this thing in front of me should also be a square, although it's a little bit oblong. So there's been some suggestions from other people on how to actually do something intelligent with the aspect ratio. And for those of you who, occasionally want to post things like, hey, by the way, here's another video on how to do raycasting. The kind of raycasting I'm doing is absolutely, definitely different than what you typically see in games. I'm doing things that, games are all laid out on a grid, and mine is not. Mine is all completely free form. So you could argue that it's actually somewhere between ray tracing and ray casting, but it's like two-dimensional ray tracing or something like that. I don't know. It's kind of goofy. I just realized I don't have this in full screen mode. Let's see. I want to enter full screen mode. Good. All right. It has the settings like I want it to have. All right. So I have a very specific plan for right now. One was to demo the fact that this is now working, and I wanted to show you how I did actually get it working. So I'm going to switch back over to the camera view for right now. I'm really not very pleased with the focal length that my camera is doing, but it seems to be mostly working. So I did do the two things that we had been talking about in the last stream, and that was doing a planar projection here. Well, that's the one part of it. And then the other aspect is I did actually put in a height adjustment code that I, stole off of Stack Overflow, as one does. So the current code for how I actually generate the set of rays that are being cast out is not drastically unchanged from the last thing that we were playing with. I just have to get to wherever that code is. This is inside the camera. I generate the set of rays, and I have a start angle that is half off of the viewing angle from the current direction that the camera is looking. The end angle is that plus the entire viewing angle. And then what I'm doing is I'm creating 2 points. So as far as our camera goes in this view, I am creating this point and I am creating this point. Then I'm generating a line segment between them, and I am evenly dividing that line segment by the number of pixels in the view. And this means, if we look down here at this diagram, that things that are further out in my viewing plane are going to actually end up with rays that are closer together, and things that are in the center are going to end up with rays that are further apart. And supposedly that helps. I'm not entirely sure exactly how all of this helps, and that's part of what we're going to do today, is look at how it helps. So let's go back here. So this is what I've done. I've created those 2 points, and then I iterate stepwise along those 2 points and generate a ray from the eyeball to one of the points on that line segment that I just created, working my way from left to right. Okay, there's actually a couple of things that I want to fix on here. So we'll fix a couple of things, but the next thing that I need to show you is the correction that I'm doing. Now, this is, like I said, stolen from Stack Overflow, well, borrowed. But the idea is that we've got this, like, well, it's a sine wave distortion. As you get closer to the wall, the size of the wall blows up because something that's closer to you is bigger and something that's further away from you is smaller. And I've got this inverse relationship here on line 396. So this is just very simple math that says, well, I'm going to do a correction based on how far off of the camera angle I am. Take into account cosine, multiply that from the distance, that gives me a corrected distance, and that flattens everything out. So I am going to write some code so that we can actually turn these features off and on, and we can see what difference they are actually making in the way everything is viewed. So I think this will work out pretty well. The one thing that I do want to correct real quick, and it's been bothering me since we last looked at this code yesterday morning, is the actual movement. So if you have the up arrow pressed, then I am moving negative 0.08 units, and that really makes no sense at all. And I need to document the coordinate system. But the coordinate system that I have here is y and x. So 0, 0 here. And if you are at 1, 1, right? So if you're pointing in this direction, then you should be moving upward along the y-axis. And I am, interestingly, compensating for that by doing negatives here. And this all is left over from when I had a very confused coordinate system. So I'm going to make those no longer negative. And I have got to correct something in my configuration here for PyCharm. And I'm going to say up is positive and down is negative, and presumably everything will still work as expected. Yes, perfect. This is how I want things to be working. That's pretty solid. And I really should change it so you actually start inside the maze, but here we are. Okay, let's stop that. So that's good. I've corrected that. I feel better about it. I can keep moving on here. By the way, super quiet. I don't see any of you chatting. I'm presuming that everything's working great. Visual Star YouTube is telling me that I've got excellent streaming connection. So, of course, if anyone has any comments or, want to be part of the peanut gallery, go for it. But I really kind of want to record every part of this process so that I can edit these things into a series of succinct episodes about the various things that I did to get here. And hopefully they can be like a little bit of a learning platform for people. And I'm really committed to trying to keep this example as small as possible. Right now it's 445 lines of code. It can be simplified in several ways, and I will do that at some point. And I also want to, again, at some point, I'm going to port this from Python to C++. So we'll call this the prototype right now. which means I do need test because I need to prove that the tests are doing the same thing in both languages. That seems like an important aspect of this. Okay, so I'm going to add the ability to switch between cylindrical projection and planar projection, and the ability to turn on or off the correction for the fisheye based off of the angle away that you are from the camera angle view. All right, so I need a couple of key press options for that. That's going to reside in here, and it's going to be another. I need to do a switch statement or something. Like I said, I'm really learning Python still. Let's get up the documentation. You know, I think I actually used to own the Effective Python book. And then I took some notes from it and got rid of it. And I've been otherwise basically doing what I did with C++ and what I'm doing with this project as well. And I'm largely just kind of trying to just try stuff and to see what I can learn and read the official documentation instead of a book, although I am not opposed to books. I have some books in my Amazon wish list right now. I'm just going to kind of see how far I get and then kind of go to the book references. And I just want to do it that way. Yeah, Match is relatively new. I haven't played with it yet. All right, let's look at key. This is the official Pygame documentation. Event. Key down. Okay, yes. List of event types with their specific attributes. That's what I thought. That I needed. Oops. Having this video playing. Oh no, it's not playing. Okay, good. What am I doing? Okay, so I need to decide which key. Oh yeah, by the way, that's a really good point. PyLinter and MyPy, I am using those to actually teach me things as well. All right, let's just, I'm just gonna use 0 and 1. No, I'm gonna start with 1. So if if the 1 key is pressed, then I'm going to toggle between planar and spherical projection onto the camera lens. That's or cylindrical. So let's try that. Yeah, let's see. I'm going to take this one step at a time. I need this open. Ooh, so much better. Wow, what a fancy tool that we have here. You all should go out and buy PyCharm. No, seriously. JetBrains is not sponsoring this, but they do make good tools. Although I wouldn't mind it if JetBrains wanted to do more sponsorship of the channel. for sure. Oh, right. Okay, I'm in Xwin copy. I thought I was... Oh, but I had edited some things, so maybe that's where I am here. Um, find previous, move previous. Select previous tab. No, that's doing what I want. Control page up. Right, right, right. Previous page. What is it that I'm looking for? Navigate back and navigate forward. Yeah, I know that I changed these. Navigate back. No, last edit location. Oh, yeah, no, this is what I want. That's fine. Remove the old one. I added it to the wrong thing. I want, like, I have years and years of muscle memory of control page up, control page down for changing tabs in a web browser, and alt left and alt right for going forward and backward in web browser history. And so using those and so inside my editor, just it makes a huge difference to me. So let's do this and this. There we go. I think this is doing what I want it to do. Planar projection is true there on the camera init. And then that was on key press 1. Key press 1. Planar projection is true, is equal to not. See planar projection. Okay, very good. And then going back to the camera and the rays. All right, that should work. That should give me the option to switch back and forth between those now. And I have like no idea how this is going to work. So we're going to give it a shot and see if it makes a difference or not, because I really don't know. Nice. I get a crash. Okay. Oh, because I'm also returning the plane point. That's the point through in the plane through which this cat array also passes, and that's further down the rays being cast out of the camera or being traced from the camera. I'm just going to return that because it was used theoretically as a different way of looking at the distance from the lens. No, I'm not going to worry about that right now. But I know that my switch worked. Oh, okay, look at that. So if I'm not doing the planar projection, then I get this kind of wonky thing happening that's not quite fisheye, but the thing that's closest, yeah, there we go, swapping back and forth between them. That's pretty cool. Oh, it's interesting. It also shifts the thing that's at the center of the view. Would have expected things at the center to stay pretty much stable. Let's get this there. Wow. Very interesting. Okay. So that is proving that doing the planar projection versus the cylindrical projection actually is making a significant difference there. So I'm going to then use button 2 to enable and disable the fisheye correction, and we can like actually see how these things go together. Oh, I'm using black, by the way, for all of my syntax formatting here, and I can't find a good way of actually executing that from inside of PyCharm, which strikes me as kind of weird, but I'm just going to go ahead and run that here. And I should see it live update. Doink. Okay, perfect. All right, so the corrected distance equals to the distance from the eye times that correction based off of the current angle if fisheye distance correction is enabled. Otherwise, I'm just going to use distance from eye. All right, and that should be on button 2. Button 2, there we go. So then we see kind of, it's weird, like if we don't have the correction and we are doing the planar projection, then things just are very strange. But if I do cylindrical projection and don't do fisheye correction, then we get this very typical thing that we drew out on the yesterday morning. But if we turn on both of those features, then everything looks nice and clean. So we are going to live in this world right now. Yeah, part of it is that I've got a big FOV, but it's not, well, some of that does need to be corrected, yes, but we're not going to deal with that right now. That's on the to-do list for later. Okay, I am going to check my notes and make sure that I am doing the things that I said that I was going to be doing. This is just for the record gratifying that things are actually working out like I wanted them to. Why can't I find my to-do list? Why can't I find my to-do list? I had it up. I really did. Instead, I have every other tab under the sun open on my computer. There we go. All right, so I showed the fixed fisheye. I explained planar versus cylindrical. I explained the corrections, and I enabled tools to toggle planar versus cylinder fisheye. Okay, I did get feedback from someone on the GitHub discussion here that said I should, Here, let's try this. What? Stop that. Slash. Raycasting. Very good. Okay, and there's some comments that we've been having. Here, streaming. Oh, that's my streaming task list, right? All right. Now, a comment here said that I need to take into account the fact that the angles are getting closer and closer together as things spread out. And PJ Fordham, who was here a lot yesterday, says that they think the new FOV angle should be 2 times the arctangent of the new width divided by the old width. I don't know what new width and old width are. Times old FOV divided by 2. So I guess that's the old FOV. Well, let's just try something here and see what it looks like. So I am here setting the FOV, which at the moment is just the width divided by the height. So I'm taking into account the fact that the height, that the width, as it changes relative to the height, we have a wider field of view. Let's see how this logic works. So I'm going to use for old width the numbers that I had in here. And my old FOV in this case is, I guess, approximately pi halves, if you will. I have to say, honestly, again, I don't really understand what the goal, this is going to look like. But let's see what we get. All right, so far it looks about the same. I guess it should, right? And I'm just going to double check. Yeah, they've got a square here. Whoa. Okay. So let's try making different sizes here. That looks pretty good. I'm still getting a square for that opening. All right, I accept that. Now let's make it ridiculously wide for the height, 1280 by 480. I should probably like put in a debug statement or something that says what the field of view is, but that looks pretty good. I'm still maintaining that approximate square shape, and I'm never seeing behind myself, so I will accept that patch suggestion here. That's not bad. It's not bad at all. All right. And yes, there is a bug right here. Let's just point that out. The thing that is smack in the middle of the window is somehow transparent or something with the latest changes that I made. I'm having difficulty with intersection detection at 90-degree angles, which now means it is time, in fact, for us to write some tests. Well, no, it was time to write some tests like 3 weeks ago when I started playing with this project. Now it's really, really past time to write some tests. Yeah, yeah, in some games you can select the FOV you want, comment on the chat here, which is I'm sure true. I kind of want the FOV to be correct and natural for what we have in this game. That's my thought process. You know what? Although while this FOV is weirdly wide, I want to go into the middle of the maze. Oh, there's another thing that I meant to discuss. Let's go ahead and cover that in a minute. Well, no, maybe I'll cover it in a future episode. Oh, it's so weird to navigate with this, although it is, yeah, correct. Yeah, okay, I like it. Ship it. The fix, so for people who are joining just now, I will go ahead and tell you that I needed two different things to fix the fisheye problem. The first was that I needed a planar projection instead of cylindrical projection, which we were talking about yesterday multiple times, Enzo, so hopefully you saw that bit. But then I did need to actually steal some code from Stack Overflow that shows how to actually do a distortion correction based off of the angle of incidence away from the center line, basically, the theta, as I think the correct way to say that. Okay, so that's good. Let's go ahead and make a commit. I want to commit that. I've never specify a commit message. Okay, very good. Let's go ahead and reference this comment. I'm so used to using git from the command line that this is very confusing to me. All right, that should be all right. All right, so now we get to have so much fun writing tests. And what I want to do is things like make sure that I can detect the intersection correctly between two different segments at the location that I expect those two different segments to in fact intersect. Oh, and I don't expect to stream for more than about 30 more minutes. And I'm not at all used to Python's unit test framework at all. But I've got the Raycasting file imported here. We're going to need to split these things up eventually. Actually, let's just go ahead and make a quick geometry file. Let's do that and move stuff into there. I think that seems very fair. It doesn't make a whole lot of sense to have all these point types and everything. Line types. Line segment. And ray. The intercept function. Intersect ray, intersecting segments, all these free functions. Yeah, those are all geometry. Where are you complaining? Too many spaces? Too many blank lines? You know, these things are highly opinionated. How do I turn that back off? Close annotations. Yeah, is that enough blank lines? All right. Why are you complaining? Unused import. It's not unused. I'm using point right there. Unresolved. Save it. No one's commenting as to what I am obviously doing wrong here, but what am I obviously doing wrong? Cannot find declaration to go to. Save. There's clearly class point right there. File. Save all. Save all. Why can't you find point? Oh, is it because I have to do geometry dot point, isn't it? Right, right. There we go. Oh my goodness. Yeah, yeah, thank you. Thank you, Christos. Okay. Let's start adding test. I'm going to rename this existing file. There should be a refactor for the file, right? Refactor, rename. Okay, there we go. I want to rename this to geometry chest. All right. So I can have multiple test cases, right? So I'm going to do something like do I want to actually name it test adding points, or do I just want to Oh, right. I don't want the equals equals there. One of you probably just comment on that. I'm intentionally not doing C++ because we're learning new things. No. And another way to think of this is that this is going to be a prototype for the C++ version. And honestly, the entire problem domain that I'm doing here, it's completely irrelevant what programming language I'm programming in. This is all about math and geometry and technique, and the programming language is irrelevant. Yes, thank you very much to everyone else here commenting on this. Okay, I'm adding 2 points. And what was I just going to do? Oh, I needed to add a note to myself about something I need to cover in an upcoming stream. So I'm doing things off screen right now. My apologies. Minutes ago. All right. Okay, sorry. My notes are updated. All right. All right, I wrote a test. Let's see if it works. Hey, one test passed. It succeeded. It's ecstatic, exciting something. Oh, I like want verbose output about what happened. Which button did I press? Did I press that one? What happens if I press this one? Same thing. What happens if I press this? Ooh, I can profile the test too. Okay, so I can add 2 points together. Very good. It's not a very complicated object there. So a line consists of a point and a slope. That's all that it is. So I don't know what tests are meaningful to put on a line. On a line segment, though, I have these things like min x, min y, max y, and the creation of a line from a line segment. Ooh, I need that in range helper function here. That's great. You know, in another programming language, it never would have compiled. Okay. All right, yeah. So I do have to do some magic here and just basically say, hey, are these values close enough? And there is an isClose function in the Python math library, but it doesn't work on a range. So I ended up sticking with this. Yeah, you know what? With the way that I'm writing this, Phoenix wire fire wings there, I expect and assume that a direct translation of this code to C++ will be about 20 to 50 times faster. It's basically like cheat mode enabled in that regard. Oh, I need math. Expected 2 blank lines. Fine. Okay, no errors found. Let's get back to these tests. I was looking at the segment class. Okay, so a segment is a line segment from one location to another. So if I create a line segment, I'm just going to go from origin, say, 0, 0, because I know that I had bugs a long time ago at origin. Hate that feature of autofill. So I'm going to go from x0, y0 to x1, y0. So I'm just going 1 over in this line segment. I need to do, like, if there's some way to automatically generate a range of these tests, that would be great. Hey, thanks a lot for the $10 tip. That's incredibly awesome. I am, just having fun here. I fully appreciate that you enjoy these things as well. So min x should be 0. That's a really lame test, I just realized. But what other properties do I have? I've got a line and the slope. So we're going to have to test some of these things. So I want the slope in this case definitely has to be 0. I'm just trying to ponder. There's got to be a better way to do this. So as if every function, so I'm going to create a local function here that is something like, yeah. Um, I have, you'll hopefully see the point that I'm getting to in just a moment. I do think that there is a point in what I'm doing right now. So the line that is going to be created should be a line that has an origin point of the segment. All right. Uh, okay. Oh, wait, I'm sorry. So, Phoenix, you said what would be the best compile flags for release? Uh, Generally speaking, -03, but in some scenarios, O3 can actually produce code that's slower than O2. So if you really care about performance, you have to do -02 and -03, compare them with each other. Then you also want to do like marc or mtune specific to the architecture that you're trying to deploy on to make sure that you can get things like your uh, what's the word I'm looking for? Like SSE instructions, vectorization, and that kind of thing enabled. And then you on Visual Studio /O2, I believe. There's a little bit of a discussion about that as the release build, but I'm not as familiar with the tuning flags on Visual Studio. Okay, so I have this test. I'm going to run this real quick. All right, that passed with no problem. Function name should be lowercase. Overkill to use the tool here, but fine. All right, so that works for something of zero slope. Now let's go ahead and do something that I know has a slope of 1. So if I'm going from x 0, 0 to y to 1, 1, then the slope should be 1. And then I want -1 slope. And that would be a y of -1, which then changes my min y to -1 and my max y to 0 and my slope to -1. And I want to verify that I created a line with a slope of -1. Invalid syntax. What just happened? Everything went to heck. And back again. Trace back, create test, blah, blah, blah. Invalid syntax on... Oh, no, I have one negative, not -1. Oh, if you're using CMake, just use the default release flags for your release build. Just it's pretty good by default. Then you might want to add an architecture tuning on top of that. Yeah, sorry, Peter. Yes, you did your your field of view works great, and now I'm adding test because I know that I have some issues. So I have a zero slope, one slope, negative one slope, and now the thing that I want is a vertical line next. And that's where things get complicated. Because if I have a slope of infinity, then I end up with math that doesn't work right. The floating point, IEEE floating point values, everything just becomes infinity or zero, and the rest of the math doesn't work. But I have to deal with the fact that I do have vertical line segments. So if I've got an x of 0 and a y of 1, then I know that I've got a vertical slope. And my min, max, max. Now, what is the slope to be? Now, obviously, I've already solved this. So I need to see what I did and then decide if it makes sense. So the slope that I'm returning, if x and x are equal to each other, is E1 E100 now. I feel like what I need is like a global, so that we all know what the deal is and we can use this. Oh no. What in the world? Stop that. Yeah, you wanted a space. Fine, you have a space now. I'm gonna do that. I'm gonna do that for right now. So it's not, quote, a hard-coded value, although it's pretty much a hard-coded value. Vertical slope. And then I need to test that I can actually construct array from this. Yes, okay. I don't know. I don't love that. No, I don't. I don't know anything about test and Python. I'm using what was suggested here, the unit test library. So yeah, if there's a better testing library, by all means, let me know. All right, those tests pass. I would love to see like the number of assertions that I'm getting and that kind of thing. So let's go ahead and pull up PyTest, since you just suggested it. Helps you write better programs. PyTest documentation. I'm gonna have to go in about 10 minutes here, but I'll pick this up probably tomorrow morning, my time, which is, if you are in Central Europe, I'll probably be on at about 5 p.m. your time in Central Europe. If you are on the East Coast in the US, then probably more like 11 a.m. Yeah, something like that. Okay. PyTest helps you write better programs. It requires Python 3.7 or PyPy 3. Well, that's the world that I'm operating in. Ooh, it looks pretty. It does things. Okay. So where's the getting started guide? Grasp its basics in 20 minutes? I want to grasp its basics in like 3 seconds, not 20 minutes. All right, import PyTest. PyTest.raises system. Okay. Why are you going to show me how to raise an error and not just how to test a thing? Okay, so assert. It uses assert. Okay, I can do that. Let's see what happens. Class, test class. So this doesn't... How does it know that these things are tests? What am I missing? I can't use inf for the vertical line because then the rest of the floating point math goes to heck. It just does. I tried. If I do that, then like nothing else works right, and I just get infinities everywhere, and it doesn't work right. I did want to do that. I promise. I tried. Did PyPy work out of the box with Pygame, or did I have to do any extra config? I just had to install it. It wasn't difficult. I'm running on Manjaro Linux, so I just had to make sure all the packages were installed correctly that it requires, and then just doing pip, it built it and installed it, and it worked fine. If you are in the UK, Phoenix, then you are quite up late. You are, I say. All right, well, I'm just going to try to import PyTest and see what happens. Which I probably don't have installed. No, I don't. So let's just go ahead and I know, you all are going to hate the way that I use pip. All right. It's installed. PyTest now works. And I'm just going to do this. And then I'm going to say see, now I'm not getting the play button automatically. Why not? What am I doing wrong? PyCharm support the PyTest. Okay. Install PyTest. I did. Create a test. Python file. Create. Go to. All right. Fine. Test. PyCharm shows the list of available tests. Create a new test. Go to test subject. I don't understand what I'm doing wrong. Oops. Because I'm also importing unit test. Oh. Okay. Yeah, I mean, it says that I can though, and oh man, I'm missing Jeopardy. Invalid syntax. Oh, because I took away the empty function parameter block. Oops. That's fair. Okay. All right, maybe that'll be a little bit cleaner. All right, I'm going to leave things off here. I am going to make a commit. All right, I'm going to go. Thanks everyone for joining me, and thank you so much, Pattius for the tip today. That was amazing, and I'll see you all later.